All right, part two. Here we go. So for these two problems, these are the electrical engineering things I had talked about. They do them with circuits and stuff. So I know you guys don't really ever look at your textbook, but the way to do these is explained in your textbook. Let me show you. Oh, that's not it. Where is it? Here we go. So like this section right here talks all about it. So I think there's an HRW problem on this, but I'll kind of talk you through it. But this is in the textbook where they do talk about it, which you can get to by clicking student resources and then in here, student edition. Okay, that is how I got to this if you don't want to get your actual textbook out. But anyways, let's do this. Okay, so in electronics, total resistance to the flow of electricity in a circuit is called the impedance. So basically, you get these diagrams, okay? All these little symbols are different impedances. So you're going to add all these things up, but you're not just going to say 4 plus 3 plus 5. It's a little more complicated than that, but you're essentially just going to add these things up. That gives you the total impedance. All right, back to the question, which is Z. The impedance is represented by a complex number. So then you add them all up. So Z in this one, so they tell us that Z is what happens when they add all these things up. You get 3 plus 4i. Cool. The other part is the impedance, which is oh, okay, so this is the other part. What is the total impedance of the circle? Perfect. This is super easy because all we're doing is we have the impedance of one and the impedance of the other. So we want to know what the total impedance is. So I'm just adding these two things together. That's all it is. So all I'm doing is adding these complex numbers. So I have 3 plus 4i. Well, so basically what I have is, let's do it up here. 3 plus 4, oops. Where's undo on Cami? I don't know. We'll just erase it. 3 plus 4i, and then we are adding the other section. So we are adding 5 minus 2i. So I just add those together. And again, remember when you're adding these imaginary numbers and complex numbers, you treat it like variables. So you're just adding like terms. So I have 3 and a 5, so that's going to give me an 8. A positive 4 and a negative 2, that's going to give me a positive 2i. Done. Okay? All right, in the circuit, the voltage is given by the formula voltage is equal to I plus Z, whereas Z is the impedance and I is the current. All right, both current and impedance are represented by complex numbers. Find the voltage if the current is 3 plus 2I and the impedance is 4 minus I. Okay, lots of big words, kind of confusing, but it's really easy. So again, V equals I times Z. So it tells us that the voltage, if the current is this, so this is I, and this is Z. So this just tells us I'm going to multiply Z times I. So I'm going to multiply these two things together. So I'm going to say 4 minus I times 3 plus 2I. And now we just FOIL. Right? So we got 12 plus, oops, not plus, minus, no, it was plus 4 times 2, 8i. All right, now we're going to go to a different color. We'll go with purple. Negative I times 3 is going to be minus 3i. Negative I times 2i is going to be minus 2i squared. Combine my like terms. We get, let's see, 12 plus 5i minus 2i squared, okay? Now remember, I squared is just negative 1, so this is negative 2 times negative 1, so plus 2, right? So we have, this becomes plus 2, right? So then we have 14 plus 5i. That is the, what are they asking for our voltage? So V equals 14 plus 5i. All right, and I'm going to share a link to this document on there, but that's those two problems. That's it. Two questions, well, 4 questions, but that way if you want to get ahead and don't want to do it in class on Tuesday, here it is. Awesome. Not Tuesday, Wednesday. You know the drill.